presenting our professional engineer's assignment subject on Hirarc case study, hazard identification, risk assessment, and risk control at laboratory. My name is Nur Izzati binti Saifuddin. My matrix number is 211092522. So first, I'll start with the introductions. So, occupational safety and health or OSH is very important to ensure a safe working environment for students, staff, laboratory use, and visitors. In engineering laboratories, students are exposed to different types of hazards because they use electrical equipment, chemicals, heating devices, mechanical tools, and sharp materials during practical activities. For this assignment, we use Hirarc, which stands for Hazard Identification, Risk Assessment, and Risk Control. Hirarc helps us to identify possible hazards in the laboratory, assess the level of risk, and propose suitable control measures to reduce the risk. Our case study focuses on the microprocessor laboratory at the Faculty of Electronic Engineering and Technology, UNIMEP.
My name is Nur Izzati binti Abdul Majid and my matric number is 2110925. For the case study, we do site visit in the microprocessor laboratory at Fakulti Pendidikan Teknologi Elektronik. There are assistant engineer who manage the lab, which is Encik Muhammad Zulkarnain bin Abdul Hamid. The maximum design capacity is approximately 30 students per station. There were workspace and quick access to emergency facilities like emergency exit. In this session, we know that there are student activity and safety aspect that students are learned in the lab of student activities. They will learn about handling electronic components, using electrical instruments, soldering, managing laboratory material like resistor, IC. Then the safety aspect. They will learn about the use of personal protective equipment, PPE. Second, laboratory rules. Third, equipment handling procedure, housekeeping practice. Emergency safety information display at the safety corner are being given in the lab. For the occupational safety and health, Regulation 2000 govern the mandatory assessment, handling, exposure tracking of volatile chemical compound. Second, Electrical Regulation 1994 and the Electrical Supply Act 1990 mandates periodic insulation resistant testing and grounding audit for all diagnostic instruments.
Assalamualaikum and good day everyone. My name is Nur Shuhaida binti Majid and my matric number is 211090979. Today, I will present my high-rate case study involving an automatic voltage regulator or AVR used in a laboratory or workshop. The main hazard identified are electric shock, overheating of the AVR, fire due to overloading, or short circuit, and damage to connected equipment. The hazard may occur because of faulty wiring, loose connection, excessive load, or poor ventilation. Based on the risk assessment, electric shock and fire have low likelihood but high severity, while overheating and equipment damage have medium likelihood and medium severity. Therefore, all hazards are classified as medium risk. To control this risk, measures such as overload protection, proper grounding, adequate ventilation, regular inspection, and compliance with safety procedure should be implemented.
My name is Nurul Adrana Najwa binti Syahri Anwar and my matrix number is 251093491. Today, I will present hazard 2 for cable management in the microprocessor laboratory. We identify poor cable management as a hazard 2. Loose, tangled, and hanging cables were observed around the laboratory workstation. Since many electrical devices are used in the laboratory, improper cable arrangement can obstruct movement and create a safety hazard. To reduce this risk, unused cables should be removed and proper cable management systems such as cable tray and floor cover should be installed. Regular inspection and good housekeeping practice must be implemented. Students should always wear a closed-toe shoes as an additional safety measure. In conclusion, poor cable management is a preventable hazard by organizing cable properly and maintaining good housekeeping practice, the laboratory can significantly reduce the risk of accident and ensure a safer environment for all users. That's all.
So the third hazard identified in microprocessor laboratory is thermal hazard from soldering electric components. This is one of the more common hazard in any electronic labs because soldering is done almost every session, and students, especially those newer to lab works, may not always practice the safest technique. Moving on, there are three main hazards that come from soldering. First is the iron itself. The tips run between 250 to 450 degrees Celsius, so any direct contact causes an immediate burn. Molten solder can also splatter and hit the skin or eyes. Second is the fumes. When flux melt, it creates compound that irritates the airway. And repeated exposure with ventilation can lead to headaches and over time even respiratory problems. The third risk if a hot iron is put down on the bench without using the stand, it can come into contact with flammable materials like packaging or cable insulation. Moving on, the risk is rated medium. The likelihood is moderate because soldering is a regular activity and technique varies between students. Severity is moderate but can go higher if the iron is left unattended or solder hits the eye. For control, we follow the hierarchy. At substitution level, students uses breadboard for early testing to reduce total soldering time. Engineering controls mean having a fume extractor at each workbench and inspecting cables before use. Administratively, students must attend a safety briefing before the first session, and are required to always return the iron to its stand when not in use. PPE is the last layer, which means safety glasses at all times, lab coat, and heat-resistant glove available at each bench.
I will continue with hazard 4. Hazard 4 is a cut and puncture hazard during the handling of electronic components. So this hazard is related to sharp materials such as electronic components, cut wires, printed circuit boards, semiconductor wafers, and glass-related materials. For hazard identification, these materials may have sharp edges, pointed terminals, or brittle surfaces. For examples, component lids and cut wires can puncture the skins if students handle them carelessly. PCB edges may also cause cuts, especially when the board is damaged and not properly finished. Besides that, wafers and glass materials can break easily when dropped or mishandled. Once broken, they can produce sharp fragments that may cause cuts, puncture wounds, or bleeding. So, this hazard can happen during circuit assembly, inspection, testing, soldering preparation, or disposal activities. It can also happen when students search through component boxes using bare hands or when sharp materials are left scattered on the workbench or floor. So, poor housekeeping can increase the risk because of small, sharp items may not be clearly visible. Although this hazard may look minor, it can still cause injury, infection, and interruption of laboratory activities. Next is the risk control based on the hierarchy of controls. For elimination, broken, damaged, or unused sharp materials should be removed from the work area immediately. Sharp waste such as broken glass, damaged PCB pieces, and cut wires ends should not be left on the table or mixed with reusable components. For substitution, safer alternative can be used where possible. For example, beginner students can use pre-cut wires, prepared components kits, or safer demonstration samples to reduce frequent cutting and direct handling of sharp materials. Okay, so for engineering control, suitable tools and storage systems should be provided. Students should use tweezers, pliers, cutters, trays, or ESD safe tools instead of handling sharp materials directly with bare hands. Component boxes should also be properly arranged and labeled. A puncture-resistant sharp containers should be provided for broken glass, wafer fragments, cuts, wires, and sharp metal component leads. For administrative controls, students should be given safety briefing before handling electronic components and sharp materials. They should be reminded not to pick up broken pieces using bare hands. Laboratory users must also clean the work area after each session and report any broken or damaged material to the laboratory staff. Finally, PPE should be used as the last line of protections. Students should wear safety glasses when cutting wires or handling brittle materials. Closed shoes should also be worn to protect the feet from fallen, sharp fragments. Suitable gloves may be used when handling broken glass, wafers, or sharp PCB pieces. So, in conclusion, hazard fall can be controlled by reducing direct hand contact, using proper tools, maintaining good housekeeping, providing proper disposal containers, and ensuring students to follow the safe handling procedures.
Then hazard 5. Hazard identification. First, burn from contact with soldering iron, more than 300 Celsius and molten solder. Second, eye injury, cause solder splash during soldering. Third, respiratory irritation from inhaling solder fumes and heat flux. Then skin irritation due to contacts with flux and solder residue. Then electric shock from the mesh cable or improper electrical connection. Trip hazard cause unmanaged wire and cable. And the last, fire risk if hot soldering iron contact flammable material or is left unattended. Then for hazard 5, risk control, which we can pretend the hazard. First, elimination, simulation or pre-solder circuit. Second, substitution, low fume solder and temperature control iron. Third, engineering, ventilation fume excitator, soldering stand, heat resistant mat. Then administrative, safety training, SOP, compliance, housekeeping, equipment inspection. And the last, wear PPE such as safety glasses, lab coat, closed shoes, and gloves.
Moving on to the discussion, looking at the overall report, 5 hazards were identified at the microprocessor laboratory. Chemical hazard came out as high risk because the consequences of improper handling, things like toxic vapor inhalation or a fire, can be severe and sometimes irreversible. The remaining hazard sits at between medium or low to medium. An important point across all 5 is that elimination and substitution are rarely an option in this lab, because removing solder, chemical, and power instrument because they are core to what the students are learning. So the controls have to be engineering and administrative measure with PPE as final backup. A key takeaway from this analysis is that PPE should never be treated as the main control. Glove and safety glasses help, but the more important step is fixing the environment first. Whether that is installing a film extractor, enforcing the soldering stand rule, or storing chemicals correctly in film hood. There are also a legal dimension to this under OSHA 1994 and USAC regulations. The university has a duty to care to maintain a safety working environment. So conducting document hierarchy is a regulatory requirement and not just good practice. For practical improvement, we recommend ensuring fume extractor available at every soldering bench, keeping maintenance record for all heating equipment, and making sure emergency procedures are reviewed with each student at the start of each semester. Ultimately, good safety habits confirmed in the lab carry over into professional engineering practice. That's all from me. Thank you.
In conclusion, this Hirarc case study successfully identified the hazards and risks associated in a laboratory or workshop. The study shows that proper risk assessment and effective control measures are important to prevent accidents, injuries, and equipment damage. Overall, Hirarc is a useful tool for improving workplace safety and ensuring a safe laboratory and workshop environment. Thank you.